we're going to solve some systems of equations. We're going to have one line, one linear equation, and one parabola, quadratic equation. Usually, if you have a line could look like that, parabola looks kind of like this. Usually, they're going to touch twice. They're going to intersect 2 times. So that means you will get 2 solutions, 2 different points. So that means we're looking for these 2 points. We're going to get 2 different answers, 2 different solutions most of the time. And those 2 points will be ordered pairs, x, comma, y, in both cases. So the way that you can go about this, yes, you could graph this. If you graph the parabola and the line, you can actually calculate the intersection. So if you're going to do that, or if you're going to do it by hand, you have to first solve each equation for y. If you're going to graph it, it needs to be y equals, so you can type it into the calculator. And if you're going to solve it by hand, that's what we're going to do also. We're going to solve it for y, so we can set the equations equal to each other. And then once we set them equal to each other, there's no more y's, we just have to solve for x. And you can solve for x by any method that you like to solve a quadratic. Factoring, complete the square, quadratic formula, whichever method works best for you. And then once you get the x value, you have to plug in both of those answers, because like I mentioned, you probably get 2 different x values. And you're going to plug each of them back in to get the y that goes with it. You could plug it into either equation, the line or the parabola, and that will work out. So here's those steps one more time. Solve each equation for y, set the equations equal to each other, and solve for x, and then plug each x in to get the y values. So here's our 2 equations. Solve for y, so that's y equals, we would subtract the 3x over. Here we would have to add the 6, so we get y equals negative 3x squared plus 6. So there's our 2 equations. As I mentioned, you could graph them, so you go main menu, graph. And it's 2 separate equations. So our first one was y equals negative 3x. The second one is y equals negative 3x squared. Oops, let me get the 3 in there. Plus 6. So we can draw, I've got a window going on here that's not going to be helpful. So you can go to, in the viewing window, select standard, which is F3. And notice it changes them to be a couple of 10s, negative 10, positive 10. It's usually going to be a better window for you. And now we can see there's our 2 intersection points. The calculator can really get those for you automatically. All you have to do is go gsolve intersect. ISCT is intersect. And here they are. There's one of them. Negative 1, 3. And 2, negative 6. So if you're using a graphing calculator, the answers are really quite simple to get. The calculator can do all the work. If you're not, you have to set them equal to each other, like I mentioned in the steps. So that means we're going to take this negative 3x, set it equal to the negative 3x squared plus 6, and solve for x. So we need to get everything on one side, so it's 0 equals. We do that by adding 3x to the other side. And now we need to solve this. This is factorable. I'm looking at all the numbers here. And we can factor out a 3, actually a negative 3. Three divided by negative 3 is negative 1, and then 6 divided by negative 3 is negative 2. If you didn't factor that out, you could actually just divide every term, including the 0, by -3, and 0 divided by -3 is still 0. So that -3 doesn't affect the problem at all. Now we have a simpler quadratic problem to solve. So this is still factorable. We can go into the 2 parentheses. The 2 numbers that multiply to be -2 and add to be -1. That would be a 2 and a 1. One of them needs to be negative to get a negative answer, and it's going to have to be the -2 to get a negative in the middle. -2 plus 1 equals -1. So this is where we get our 2 answers for x. Solving each of these, x minus 2 equals 0, x plus 1 equals 0. So x equals 2 and x equals -1. If you look at the answers we got from the calculator, x equals 2, x equals -1. So we know we're on the right track. All we need to do now is plug in each x solution to get the y value. Pick either equation you want. I would always recommend choosing the linear equation, the one without the x squared. It's a lot easier to plug into. So y equals -3x. So let's just continue this right here. Y equals -3x. So when we do that, that's -3 times 2, which is -6. Or -3x, so that's -3 times -1, which is a +3. 2, -6, boom, -1, 3, boom. Just make sure you write your answers as ordered pairs, just like we did here. 2, -6, and -1, 3. So, quick review. In order to solve, you get y equals. If you're able to graph them, just graph them and calculate the intersection. If not, you set them equal to each other. Solve by any means necessary. In this case, we did factoring. Get our 2 x values, plug them back in to get y, and write your answers as an ordered pair. Let's try another one. Solve for y. And the other equation, solve for y, get y by itself. So y equals x minus 7, y equals x squared minus 7. As mentioned in the last problem, if you graph those, x minus 7 and x squared minus 7, you can see it looks like they intersect. It's hard to tell from this window if they intersect once or twice. G-solve intersect, 0, -7. And then if you try to find the other one, just push to the right, 1, -6. So they do intersect twice. Or if you don't have a calculator, you solve it by hand. You set them equal to each other. So x minus 7 equals x squared minus 7. This is actually pretty easy to solve because once we get everything on one side, so I'm going to move the x over, subtract the x, and add the 7. So we get nothing on one side, 0 on one side. Then writing it in standard form, x squared goes first, then minus x, and then -7 plus 7 cancels out. That's 0. And this is obviously factorable because they both have x. So factor out the x. We have another x minus 1. So to finish this equation, to finish solving it, we set each factor to 0. So x equals 0. There's one answer already. X minus 1 equals 0, so x equals 1. Now the final step is to get the y values by plugging it back in. Pick whichever equation is easier. It's always going to be the line, the one without the x squared. Y equals x minus 7. So x is 0. 0 minus 7. That means y is negative 7. Y is x minus 7, so that's 1 minus 7. That's negative 6. So we have our two ordered pairs, 0, negative 7, and 1, negative 6. Same as what we got from the calculator. So we've got one more example I'll do here. Y equals for both of these. So getting y by itself, we subtract the 6x. And getting y by itself, we subtract the 7. Again, you can graph these. This time I'm going to just trust my algebra and not graph them. So we set them equal to each other. Negative 6x minus 16 equals x squared minus 7. And then get it equal to 0. So move one side over. So add 6x. We'll also add 16. So there's nothing left on the left side, just a 0. And then writing it in standard form, x squared plus 6x, negative 7 plus 16, it's 9. So again, this is factorable. Two numbers that multiply to be 9 and add to be 6. That's 3 times 3 and 3 plus 3. So when we solve this, we get two answers, sort of, because it's the same answer. Now, we know that since it's the same thing, when we plug it in, we're going to get the same answer both times when we plug it in to get the y value, which means we're not going to have two answers like we did on those last examples. We just have one answer, negative 6x minus 16. Plug in the negative 3 there, so that's negative 6 times negative 3 is 18, minus 16, we get 2. So the y value is 2, negative 3, comma 2. And we know if we would have plugged negative 3 in again, we'd get the same answer. So we only have one solution this time. So I kind of lied. I'm going to graph it now just to show you what that looks like. Negative 3, 2. So our first equation is negative 6x minus 16. And the second equation was x squared minus 7. That's convenient. I already have that typed in from the last problem. So we draw that. Now when you look at this, we see the line, we see the parabola. They get kind of mixed up there. It's kind of hard to tell which one's which. And when we go to G-solve intersect, we get negative 3, 2, which is good because that's what we wrote here in box to put our answer around. And if we push left or right to try to get the other one, we see nothing. Nothing happens. Nothing changes because there's only one answer. So what's happening here is we have the parabola and the line just kind of touches it but never passes through it, so it never gets another answer. It's kind of like a tire from a car or a bicycle on the road. It just touches it. If we had a circle and the road passed through it, there'd be something wrong with it, obviously, if we had a wheel on the road pass through it. So it's sitting right on it. That's actually a mathematical term. It's called tangent. That's not super important at the moment, but that is what that's called. So the reason there's only one answer is because the line is tangent to the parabola. So there's only one answer going on.